Hello everyone, in this virtual lab we're going to discuss the Young modulus. A stiff material has a steep stress-strain graph. This is because a large stress is needed to produce a given strain. The gradient of the graph is thus a measure of the stiffness of the material. We call the gradient as the Young modulus of a material. Let's click Definitions and recall the definition of Young modulus. So, Young modulus is the gradient of the initial straight part of the stress-strain graph. This part right here. The part where the stress is proportional to the strain and where the material obeys Hooke's law. The Young modulus is calculated using stress divided by strain, which is the gradient of this graph, or what is known as the slope. The slope, or the gradient, is calculated by choosing 2 points on the graph, and thus it's equals to y2 minus y1 divided by x2 minus x1. The Young modulus is a measure of the stiffness of a material, and it's measured in gigapascal or gigapascal. Now let's select aluminium, and we're going to find the Young modulus for the aluminium specimen. Let's select graph with a stress-strain relationship. And we're going to load the material until it snaps. If we move the cursor over the graph values of stress and strain, it appears in the X and Y windows above. We should select 2 points on the graph in order to calculate its gradient. Let's select this point and this point. And the triangle that we're going to use to calculate the gradient is highlighted here. Let's click Calculate to use this panel that will help us calculate Young modulus using the data from the graph. So the Young modulus is equals to stress divided by strain. We will substitute the values of y1, which is equals to 90, minus y2, which is equals to 69, divided by x1, which is equals to 1.3, minus x2, which is 1.02. So what's your value? We will click on Calculate to check the answer. So the Young modulus is equals to 75 gigapascal.